Hi everyone. Today we're going to learn how to graph linear equations 3 different ways. So the 3 ways we're going to learn to graph linear equations are going to be by using a table, using the intercepts, and using the slope and y-intercept. We're also going to have a quick explanation about vertical and horizontal lines. Today, we're going to be using both formulas of linear equations, the standard form, ax plus by equals c, and our favorite slope-intercept form, y equals mx plus b. So let's get started. So the first way we're going to learn to graph is by using a table. Oops. Okay. So when we use a table, we have to make sure that we have our table, which is going to be x and y. We like to pick at least 3 points, although just so we're aware, any 2 points will make a line. That's going to be important to us a little bit later. All right, so I need to pick some x. That way, when I do all my math out, it's going to give me my y. So I like to always try and use a positive, a negative, and 0. So I'm going to use a positive 2, 0, and a negative 1. Lots of people like 1, 0, negative 1, 2, 0, negative 2, whatever works for you. I'm just going to use these 3 points right now. Okay, so the first thing I'm going to do here is substitute this 2 in. So to do that, I would have y equals 3 times 2 minus 2. 3 times 2 we know is 6, and 6 minus 2 is 4. Therefore, y equals 4. So I'm now able to fill in the y piece of my table. The second one, or the second coordinate that we need to put in, is 0 in for the x. So to do that, I'm going to say 3 times 0 minus 2. 3 times 0 we know is 0, and 0 minus 2 is negative 2. So now I have the y coordinate for that x. And the last one I'm going to do is substitute in that negative 1. So 3 times negative 1 minus 2. Again, we have to remember our integer rules because 3 times negative 1 is going to be a negative 3 minus 2, which will give us a negative 5. And now I filled in my y coordinate for that piece. So now we're going to graph. So in our last video, maybe not our last one, but one of our other videos, we learned how to graph using or plotting points. So we noticed that these aren't really in coordinates yet, but if we wanted to, we could make these ordered pairs. 2, 4, 0, negative 2, and negative 1, negative 5. Okay, so now what I'm going to go ahead and do is plot those points. So we do remember to start at our origin. I'm going to move to the right 2 since it's positive, and up 1, 2, 3, 4. I'm now going to graph 0, negative 2. Since it's a 0 for my x, I'm not moving either way, left or right, but I am going to move down 2 on my y-axis because that's going to be a negative. And then our last coordinate is negative 1, negative 5. So I'm going to move to the left, negative 1, since that's where our negatives are along our x-axis, and then I'm going to move down 5. So what we notice is we have 3 points. What we should also notice is that if we could connect them all, which we're about to do, we're going to form a line. Sorry about all that noise. All right, so here's our line that we just made. And again, as long as we're plotting all of our points correctly, right now they should all form a line because these are linear line equations. Okay, so let's look at our next example of graphing using a table. So if we look here, we have a fraction. So this is where it gets a little bit tricky whenever we have fractions. So we notice that our denominator is 3. Anytime we're working with fractions, I always like to choose multiples of whatever that denominator is. So for instance, we could have something like 3, 0, and I'm going to say negative 6, only because I do want to continue having that negative in there. And again, because our denominator is 3, we could have used 3, 6, 9, 12, 15, 18. Any of those multiples would have worked. Then we're going to do some math out. I'm not going to waste a whole lot of time on this. But we should be more comfortable substituting in that 3, multiplying by 1/3. 1 minus 4 we know is going to be -3. If we substitute in 0, that's really nice because it's like we can cover up all this. Again, this is going to be important when we are graphing using intercepts. And I'm left with -4. And then if we multiply -6 times 1 is -6, divided by 3 is -2, minus 4 gives us -6. So we've done our math, and now I'm going to plot my points. I'm not going to write them in ordered pairs this time just because I know which way to move on my x and which way to move on my y. So we have our first point. Then we have 0, -4. Again, we have to be careful about that 0. And -6 and -6. If we notice, we do have a line, and I'm going to use my awesome dog-chewed Crayola marker box ruler. I wish I could have hit all those points, but I didn't. Good ruler there. All right, but we can see that we graphed that line. Okay, the last equation that we're going to look at when we're using a table is going to be a little bit tricky. This is actually not my favorite way to graph this type of equation, and we're going to see it a little bit later on. What we should notice is that this is actually no longer written in slope-intercept form. We have this written in standard form. So because using slope-intercept form was so easy for us to make a table, all we did was have to input an x value and then get our output of a y value. I want to go ahead and I want to put that in slope-intercept form. So we remember from our writing linear equations, the way to do that is to subtract x from both sides. Again, these aren't like terms. Our x's are gone, so we're left with 2y equals 2, -x minus 6. And I only wrote this again this way because we like our x term first as we're working with slope-intercept form. It helps us to make it a little bit easier to identify our slope. I do want my y isolated, so I'm going to divide everything by 2. 2's are gone. This looks kind of interesting, so we're left with y equals, and we have to remember anytime we don't see an x a coefficient in front of our x, we know that that's going to be that invisible 1. So this is actually going to be -1/2 x, and then 6 divided by 2 is 3. So -3. We're working with another fraction. Again, we know our tip as we work with fractions is to pick multiples in our denominator. And just for fun, I'm just going to use 2, 0, and -2. It's going to make this kind of nice and easy. So the first thing I'm going to do is, again, do some math. I'm not going to show you here. We should start to be feeling comfortable with that. 2 times -1 is -2, divided by 2 is -1, minus 3 gives us a -4. 0 times -1/2 is 0. Minus 3 is just -3. And then -2 times a -1 is a +2 divided by 1. Divided by 2 is 1. And 1 minus 3 is -2. So now that we have all of that, we can go ahead and graph our points. One of the things I didn't say earlier, but I will say now, is if we look very closely at that slope, we remember when we first saw our slope video that we learned there were 4 different types of slopes, positive, negative, undefined, and 0 slope. This is a negative slope, so we should expect to see our line going down somehow. So let's graph these points and let's see if that's going to work out. So I'm going to move to the right 2, down 4. 0, I have that 0 again, so I'm not going to move left or right, just move down 3. And then to the left, 2, and down 2. And again, we do see this line. I'm going to try and hit all the points this time. Okay, that's not going to work out for me very well. Oops. There we go. Okay, I got a little crooked at the end, but hopefully you get the idea here. I should have a ruler, I know. Okay, good so far? So now we're going to graph linear equations by using intercepts. We remember from possibly the slope video, no idea, that our x and y intercepts are where x is 0 or y is 0. It's by definition, it's where they cross the x or y axis. So we're going to start off with our x-intercept. And so the way we do this, I just have a quick way that I like to do this. We know that our x-intercept as a coordinate is written where our y is 0. And this works especially well with standard equations. And when we look at our coefficients, we should start to see some kind of similarity, not similarity, but some kind of relationship between our coefficient of our x, our coefficient of our y, and our constant that we have here. And so hopefully we do have that relationship recognizable to us. So what I'm going to do to find my x-intercept is, since we know our y is 0, I'm just going to go ahead and cover up that y. So if this were my equation, 4x equals 12, what times 4 equals 12? Hopefully we know that it's going to be 3. Okay? And I'm going to do the same thing for y. Again, graphing using intercepts works especially well when we have two things. One, an equation written in standard form, and two, when we have a relationship between all of those numbers that we see, the coefficients and the constant. For our y-intercept, we remember that's when our x is 0. So what I'm going to do is I'm going to go ahead and cover up my x term. And now we have 3 times what number equals 12? What number is that? 4. So now that I have that, those are the only 2 points we need. When we were graphing using tables, we like to find 3 points just because it's a little bit easier to work with 3 points in the event that we've miscalculated something. But when we're working with our intercepts, all we need is these 2. So our x-intercept, 1, 2, 3, and our y-intercept, are graphed. And so now all I'm going to do is connect those 2 dots. Okay, getting a little bit better, I think, on making that line. So there we go. That's all we need to graph using intercepts. So we're going to try a couple more examples just because there's going to be some changes. So look very closely at what's happening right here on number 1. And I'm actually going to skip to number 2. I mean, I lied, number 4. So here's our 4th example. And I'm going to do the exact same thing. First, it is written in standard form, so we like that. Hopefully we see a relationship between all of those numbers that we have here. So I'm going to first find my x-intercept. And again, to do that, we know we have to cover up our y. And when we do that, we know that 2 times what equals 6? Hopefully we know it's 3. And for our y-intercept, I'm going to cover up my x term, and 3 times what equals 6? So now that we have our intercepts, all we need to do is graph these. So 3, 0, and 0, 2. And we're going to make that line. Oops. All right. Next, we're going to see our next type. Look very closely at how 4 has been written and how we saw 1, because it's all about to change right here on 2. So the first thing I said is we need to make sure we remember it's written in standard form. And standard form for us is ax plus by equals c. Notice anything interesting here? Hopefully you guys see that our x and y terms are switched. So we can either work with those or we can rewrite it. Either way, I just like to rewrite it because I like things to truly be in standard form. So I'm going to go ahead and rewrite that. And to do that, remember we do have to take the sign in front. So this would be negative 4x plus 3y equals to 12. So now that makes me feel a little bit better about having it written in standard form. Again, because we're using our intercepts, we're just going to substitute in zeros for y and for x and fill in those x and y coordinates. So again, to find our x-intercept, I need to cover up my y. And what times negative 4 gives me a positive 12? So this one's kind of interesting because we actually have a negative 3 here. And when we look at our y-intercept, what times 3 gives me positive 12? Hopefully we see that it's 4. So next I'm going to graph those. And we have our next line. All right. And the last example that we're going to see is actually not a great example of intercepts. Again, we know that the reason why we have so many different ways to solve things in math is because there's always a breakdown. So what we have to first notice about this last example, number 3, is that it's not written in standard form. It's written in slope-intercept form. Not only that, do we see anything kind of odd about this? I can definitely identify my slope, but do we even have a y-intercept? No. And so we talked about this before. When we don't have a y-intercept, we know that it's 0. If I went ahead and still tried to use intercepts and covered up my x and covered up my y, I would actually be left with 0, 0 being the intercept for both. And that's fine, but when I took the time, or when I take the time to graph 0, 0, I'm only able to graph 1 point. So this is interesting because I still need at least 1 more point to make a line. I have no idea which way this line is. Well, I should. It's positive slope, so we know it's going up, but I don't know how it's slanting up. So what I'm going to do is I'm actually going to resort back to table on this. Again, sometimes we can use different ways to solve things, and when we can't, we have to have an alternative way. So if I went ahead and went back and made a little table here, we already know x and y are going to be 0, so I'm just going to go ahead and pick -1 and +1 just to save us some time. So -1 times 3 is -3. And +1 times 3 is 3. So I've already had 0, 0 graphed. So now I'm going to move to the left 1 and down 3. And to the right 1 and up 3. And again, if I go ahead and graph this line, we can see that that's what that graph looks like. So the last way we're going to see to graph is using the slope and y-intercept. And this is by far our favorite type of way to graph. And there's several different variations we can see. So we have to remember that slope and y-intercept come directly from slope-intercept form, where m is our slope and b is our y-intercept. We definitely know that about our slope-intercept form. But what we don't know is what the m and the b stand for. And so now this is what we're going to learn. So the first thing we have to know is the y-intercept is where we begin. And the slope tells us how we move. We have to remember that it gives us a rise and a run. How much we're going to go up and down versus how much we're going to move left and right. And that's really important for what we're about to see when we graph. So if we look, we're told our slope is 2/5. That means I'm going to rise 2 positive, and I'm going to run 5 to the right because that's positive. And we know that our y-intercept is -1. So we were just told that that's where we begin. So what I'm going to do is I'm going to just graph this point -1. Next, I'm going to move. So I have to rise 2, 1, 2, and run 5. 1, 2, 3, 4, 5. So this is going to be my next point. Again, all we need is 2 points. So what we can do next is go ahead and graph that line. Okay. Hopefully that was pretty easy. If we look at number 2, a little bit trickier. Why? Well, it's written in the equation. We don't have the given slope and the y-intercept for us. So we have to find those. So the first thing I want to do is find those 2 pieces of information. Told you they were the most important. So our slope we know is -3/5, and our y-intercept is going to be 1. So I'm definitely okay with graphing my beginning point here at 1 along my y-axis. What I'm not so sure about is this negative. So earlier I tried to at least, write that negative in the pot in between our numerator and denominator, right in the middle. But if you notice, I actually tend toward my numerator, which is fine. So what this means, because I'm going to keep that negative with my numerator, is I'm going to rise -3. Well, because I'm rising a negative, I'm actually going down 3. Since my denominator is positive, I'm still going to move to the right 5. So from this point, I'm going to move down 1, 2, 3, and to the right 1, 2, 3, 4, 5, and have my point. But before we actually graph this line, what I want you guys to see is what happens if I would have put the negative with the denominator. Where would that be? Well, if we go ahead and do that, that's going to mean we're moving up 3. And because it's a -5, we're going to be moving to the left 5. So starting from that beginning point, I'm going to move up 1, 2, 3, and to the left 1, 2, 3, 4, 5. Well, if we look, what do we notice about all 3 of those points there? Hopefully we can see that they all lie on the same line no matter what. So that negative, earlier when I said it kind of doesn't matter where we put it, it doesn't, because when we're graphing, we can see it's going to lie on the same line, all of those points. It's just going to be dependent on how we feel most comfortable. If we're okay with having it in the numerator or if we like it in the denominator. Just an aside, one of my former students always liked to have it in the denominator because she said when you rise, you go up. So why would you ever rise and go down? And it worked for her. So if you want to always have a positive numerator and just move left or right, do it. If you don't mind, that's great too. So we're going to look at 2 more examples. Example 3 is going to be very similar to what we just saw with example 2. I have it written in an equation, so I have to find my slope and y-intercept. So my slope, -3/2, and my y-intercept this time is actually a negative. So I'm going to begin down here at 2, and then I'm going to go down 3, 1, 2, 3, and to the right 2, 1, 2. But again, if you decide rise always means going up and you want to make your slope 3/-2, you could go up 1, 2, 3 and to the left 2. And again, you're still going to be on that line. Not going to use the Crayola box for this, hoping that I hit all the points. Kind of a straight line. We'll see. And the last example we have, again, I just want to use it as an example to show you guys that yes, we can use slope and y-intercept to graph a line like this. However, not my favorite. The reason is it's in standard form, and we know that this is our invisible 1 right here. So 1, 2, and 6 actually have a relationship. So I prefer to graph this using y and x intercepts or using intercepts. So that's what I would do, but because we need to be able to know all different ways, the first thing we have to understand is to graph this using slope and y-intercept, it has to be in slope-intercept form, which is our good old y equals mx plus b. So what I'm going to do is go ahead and move my 1x from both sides. So I'm left with 2y equals to -1x. Plus 6. Again, I like to write where my x term is first. Then I'm going to have to divide each term by 2. And again, I stick my negative with my numerator all the time. So once we have that, we can now identify our slope and y-intercept. Our slope is going to be -1/2, and our y-intercept is 3. So I'm going to begin at +3, and I'm going to move down 1 and to the right 2, or if we wanted to, we could really have that negative with the denominator and move up 1 and to the left 2. Oh, I forgot to draw my line. Didn't hit all the points, but you're getting the idea, I hope. So the last thing that we're going to see today are going to be vertical and horizontal lines. So we're going to start with vertical lines. And this is actually the equation of a vertical line. X equals 3. So why is this so interesting? It's not written in slope-intercept form necessarily or in standard form. But what we should notice is we have one variable, just x. So I'm actually going to graph this starting off with a table because it's easier for us to see how this becomes a vertical line. So we're told that x equals 3. So it doesn't really matter what y's we pick. So I'm going to put -2, 0, and 1. Again, the thing that we care most about is that x is 3. And we can really see that all of our x's are 3. So now if I graph those points, and again I just chose random points. 3, -2, 3, 0, 3, 1. Well, if I connect all of those points, I do end up with a vertical line. So this is the reason why we know that anytime we see an x equals, it's going to make 1, a vertical line, and 2, when we talk about this slope, we have that undefined slope. Okay, so this one should be a lot nicer on the second example. We know it's x equals -4, so all I'm going to do here, instead of making a table, I'm just going to move over here to -4 on my x-axis, and I'm just going to draw a line. Vertical line. There we go. Pretty easy? Okay, so if we can see that x equals a vertical line, what do we expect y equals to be? Yay! Hopefully you got horizontal lines. If we notice, again, we don't have any x coordinate here or any x term here at all. So just so that we have our visual proof of this, I'm going to start by making my table. All I care is that y is -3. Doesn't matter what my x is. So if I go ahead and see x is -2 and -3 and 0 and -3 and 2 and -3, we end up still with a horizontal line. So anytime we see a y equals with no x, we know that that's going to be a horizontal line. And what kind of slope did this have? That's right, a 0 slope. So everything's all interconnected. And then the last thing that we're going to see is y equals 1. Again, we don't have an x. We know y equals. Anytime we see that is going to produce a horizontal line. So I'm just going to come over here, put a point there at 1, and then draw my horizontal line. Good? Great.